Dispersion forces. Dispersion forces are found in non-polar molecules such as non-polar molecules such as O2, N2, Cl2, etc. And monoatomic noble gases. Monoatomic noble gases like helium, neon, etc. Okay. So, in the case of non-polar molecule, we know non-polar atom or molecule contains a positive center and it is surrounded by symmetrical electron cloud. So, like this. Positive center and it is surrounded by symmetrical electron cloud. Let it be A. And take another atom, positive center, and it is surrounded by symmetrical electron cloud. Let it be B. So, in this case, at the stationary state, this will be the case. Okay, when this electron cloud oscillates, it may become dense on one side. That is, electron cloud will become dense on one side like this. Okay, when this electron cloud oscillates, this electron cloud shifts to one side and will be dense on one side. And what happens? And there produces an instantaneous dipole. Instantaneous dipole is produced in the case of atom A. Okay, so due to this instantaneous dipole, the next atom, atom B, is very close to this atom A. So this distorts the electron cloud of the other atom, and this again, this atom B also shifts like this. Okay, so in this case, in the case of atom B, there causes an induced dipole. Okay, so atom A induced a dipole in the nearby atom B, and it attracts this positive side. This electron cloud attracts this positive side of atom B like this. Okay. Okay, like this. So, like this, large number of non-polar molecules becomes temporarily polar. Okay. Large number of non-polar molecule becomes temporarily polar. So due to this polarity, these two atoms attract each other with a weak attractive force. Okay, that is, there is a mutual attraction between these force by weak attractive force. This force is known as dispersion forces. Okay, these are very weak and it operates in all types of molecules. This is very weak and this is a weak force. Okay, and it operates on all types of molecules. Next, this dispersion forces was first proposed by German physicist Fritz London. So, these forces are also called as London forces. Okay, also called as London forces. Okay, these forces, dispersion forces, are always attractive forces, and there will be interaction energy in the case of these molecules, and this interaction energy is inversely proportional to interaction energy is inversely proportional to the sixth power. sixth power of the distance between the constant molecules. Okay, of the distance between the constant particles. Okay, constant particles. Okay, so let r be the distance between two interacting particles. Okay, let r be the distance between these interacting particles. So interaction energy is inversely proportional to the sixth power of the distance between these two interacting particles. Okay, and these forces are only of a short distance, and this distance is approximately equal to 500 pm. Okay, so it is a very short distance, and this is a very weak force also, and the magnitude depends upon the polarizability of particles. Okay, magnitude of these forces depends upon the polarizability of these particles. Polarizability. Polarizability of these particles. It's much about the dispersion forces.